Chapter 1, Fundamentals of Algebra. We're going to begin this chapter looking at section 1-2, Polynomials. First thing we want to discuss, exponents, exponential notation. There are, of course, several properties of exponents. We will be looking at those properties later on, but today we're just going to be focusing on this one. If you have any base a to the nth power, that just means that base is being multiplied by itself n times. So if you had 3 to the 4th, for example, that just means 3 times itself 4 times, and you get, of course, 81. If it's numerical, you can use your calculator. Doesn't matter to me. For example, let's look at these. So, number 1, the quantity of -2 to the 6th. What this actually means is -2 times -2, blah, blah, blah. 6 times, you perform the product and you get what? You get 64. If it's simply numerical, just use your calculator, that's fine. This one is definitely different than number 1. Why? Because the negative is no longer in parentheses. So what this actually means is -1 times 2 times 2 times 2 times 2 times 2 times 2, which would be equal to the opposite of the answer we just got in number 1. All right. Again, if you wanted to really write this out, I don't know why you would, but you could. But if they're numerical, just go ahead and use your calculator. That's fine. I'll go ahead and show you a couple steps on this one. If you wanted to do this separate, the quantity of -2/3 squared would be 4/9. And the quantity of -3/4 cubed would be, that'd be -27 over 64. There we go. And if you really wanted to, you could reduce here. 4 goes evenly into 64 16 times. 9 goes evenly into -27, -3 times. And so your final result is -3/16. Notice every answer I'm boxing in. If you were taking a paper test, that is how I'd want you to notate your answers. When you show me your work on your test, I would like you to box in every solution so it's quicker for me to check. All right, those are numerical examples. So let's continue. All right, so another law or property of exponents is this one. If you multiply like bases, you add the exponents. If you multiply like bases, if these are the same, I don't care if they're 2 numbers or 2 letters, variables, if you will. If they're the same and you're multiplying them together, you add the exponents. Here's an example. Now, of course, this is, again, numerical. So, if you wanted to leave it in exponential form, yes, you should know this law. But if you wanted to simplify this completely, you could just simply use your calculator because it's all numerical. All right, so let's take a look at example number 1. In this case, you have like bases being multiplied together. This one's being raised to the 2nd power. This one's being raised to the 3rd power. So following that law of exponents, you'd get the quantity of -3 to the 5th power. Again, it's all numerical, so if you like, you can use your handy-dandy TI-84 and simplify this completely to get -243. Okay, they're not always going to be this easy, though. In fact, for the most part, you're going to be looking at algebraic expressions such as this one, so that you have not only what's called a numerical coefficient, you also have a variable component as well. In this case, our variable is, of course, x. Well, notice again we have like bases being multiplied together. So I'm going to go ahead and write down whatever the like base is, and then what I want to do is look at the 2 exponents. I'm going to now add 3 plus 5 together. And that's going to give me 8. At this point, what we have actually is a product to a power. We'll look at that law formally later on, but I'll go ahead and just go over it with you right now. So what this means is actually the quantity of negative 2 to the 8th power. You can do that in your calculator. The quantity of negative 2 to the 8th power times x to the 8th power. Again, this numerical part you can do in your calculator. So negative 2 to the 8th, put in your calculator, you get 256. Then x to the 8th, guess what, is x to the 8th. And you're finished. The next thing we want to look at in section 1.2 is the definition of a polynomial in one variable. So, blah, 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 blah. Bottom line is, you should be able to recognize if something is a polynomial. How do you do that? Well, you have real number coefficients. Normally they'll be integer, or what are called integral coefficients, integers, negative 3, 7, negative 1, etc. And also the exponents are all whole numbers, okay? Whole numbers. So in other words, what this really means is 4x to the 0. What this really means is negative 9x to the first. Every single base x is raised to a whole number exponent. If that's true, then it is a polynomial. What we need to be able to do with polynomials at this early point is add them, subtract them, multiply them. Okay? So let's go ahead and get started with adding and subtracting. Let's just go ahead and look at example number 1. So in this case, what we're trying to do is determine if we have any like terms. So what is a like term? Well, a like term is a term that contains the exact same variable base and the exponent that variable base is raised to is also the same. So for example, here we have 3x squared, and we also have a negative 2x squared. Note, the x squareds are identical, making them like terms. We also have a plus 5xy and a minus 3xy. Those are another pair of like terms. So now let's go ahead and simplify this addition operation. So 3x squared minus 2x squared. 3 minus 2 is 1. You get 1x squared. Or you could simply just write x squared. Now we look at 5xy minus 3xy. 5 minus 3 is 2. So we have 2xy's. Notice these are unlike, so you don't just forget about them. You go ahead and write them down. You just bring them down and write them in your final result. There you go. All right, number 2. Definition of subtraction is going to be used here. And so what does that mean? Well, let's go over here real quick. Definition of subtraction would be if you have a minus b, that is exactly the same as a, add the opposite now. Add the opposite. Definition of subtraction. A minus b equals a plus the opposite of b. So we're going to use this definition to help us answer this question, or help us to simplify this expression. Okay, so here we go. Notice there's a negative here. All we're really going to do, in essence, is distribute the negative through every one of these 3 terms. So let's go ahead and do that. Here we go. Add the opposite, opposite, opposite. Now we're ready to rock and roll. We have a 2x squared, 1x squared. Minus 3x, minus 2x. Plus 4, plus 6. 3 pairs of like terms. Let's go ahead and combine them. So 2x squared plus x squared, 3x squared. Negative 3x minus 2x, negative 3 minus 2, that's negative 5, and x is the like term. Plus 4 plus 6, 4 plus 6 is 10. And that's it. Finished with example number 2. The next thing we want to do is look at multiplication of polynomials. So within that, we're going to talk about the distributive property, okay, at some point here. And number one, we don't need to use the distributive property. There's nothing to distribute. We're just going to be multiplying these three terms together. Okay, so how do we do that? Well, first thing we're going to do is look at their numerical coefficients. All right, so we have -2, 4, and 2. We've got to multiply all three of those numbers together. So -2 times 4 is -8. Then -8 times 2 is -16. The next thing we have to do is identify all of the x bases. Remember what we're going to do here. When we multiply like bases, we're going to add exponents. So let's go ahead and write down the like base, and then let's, at this time, add the exponents together. This is really x to the first, right? X to the first, as is this. So we have 1 plus 2, that's 3, plus 1, that's 4. Finished with the x base. Moving on to the y base. We just have a pair of those. We have y squared times y squared. Again, when you multiply like bases, you add their exponents. So you'd get 2 plus 2, which is 4.